Hello everyone, welcome to Zoom in Data. In this AI 900 learning series, we will learn the fundamental concepts of artificial intelligence and explore Microsoft Azure AI services. This series is designed to help you understand the key concepts required for the AI 900 certification. Classification is a supervised machine learning technique used to predict a category or class for a given input. The model learns patterns from historical data where the correct class or label is already known. Classification can predict categories such as spam or not spam, fraud or legitimate, or low, medium, and high risk. It is widely used for decision-making tasks, where the expected output is a discrete category rather than a continuous numerical value. Classification models are trained using examples that contain input features and their corresponding known class labels. During training, the algorithm learns patterns that help distinguish one class from another. After training, the model analyzes new data and predicts the most appropriate class based on the learned patterns. Many classification models can also produce scores or probabilities that indicate the confidence associated with their predictions. Features are the input variables used by a classification model to identify patterns in the data. The label is the known category that the model is trained to predict. For example, an email can use sender information, message content, and other features, while spam or not spam is the label. Selecting relevant features and providing representative labeled data can improve classification performance. Binary classification predicts one of two possible classes for each input. Common examples include spam versus not spam, fraud versus legitimate, and approved versus rejected. The model learns a decision boundary that separates the two classes based on the available features. Binary classification is commonly used when a business problem naturally has two possible outcomes. Multiclass classification predicts one class from three or more possible categories. For example, a support system can classify a customer request as billing, technical support, account access, or another category. The model learns patterns that distinguish multiple classes from each other using labeled training data. Multiclass classification is useful when the problem requires selecting one category from several possible outcomes. Common classification algorithms include logistic regression, decision trees, random forests, support vector machines, and neural networks. Logistic regression is commonly used for binary classification and can produce probabilities for class membership. Decision trees and ensemble methods can model more complex relationships between features and classes. The choice of algorithm depends on factors such as dataset size, feature types, performance requirements, and interpretability. Classification models are evaluated by comparing predicted classes with the actual labels in the test data. Accuracy measures the proportion of predictions that are correct across all classes. Precision measures how many predicted positive cases are actually positive, while recall measures how many actual positive cases were identified. F1 score combines precision and recall into a single metric and can be useful when both are important. A confusion matrix summarizes classification predictions by comparing predicted classes with actual classes. True positives and true negatives represent correctly classified positive and negative cases. False positives occur when a negative case is incorrectly predicted as positive, while false negatives occur when a positive case is incorrectly predicted as negative. Confusion matrices help identify the types of classification errors that a model is making and support calculation of precision. Classification is widely used for spam detection, fraud detection, customer churn prediction, and medical risk categorization. Businesses can classify customer feedback into categories such as positive, negative, or neutral. Financial systems can classify transactions as legitimate or potentially fraudulent based on learned patterns. Classification can also support image recognition, document categorization, recommendation systems, and automated decision workflows. Azure Machine Learning can be used to build, train, evaluate, deploy, and manage classification models in the cloud. Developers can select suitable classification algorithms based on the dataset, business requirements, and expected model performance. Automated machine learning can evaluate different algorithms and configurations to help identify an effective classification model. Azure Machine Learning also supports model deployment, monitoring, and lifecycle management for production. Classification is a supervised learning technique that predicts discrete categories or classes from input features. Binary classification predicts between two classes, while multiclass classification selects among three or more possible categories. Accuracy, precision, recall, F1 score, and confusion matrices help evaluate classification performance and understand prediction errors. Understanding classification and recognizing category-based prediction scenarios is an important machine learning. Thanks for watching this AI 900 learning video. For more learning content, tutorials, and real-time projects, stay connected with Zoom Data. Visit our website, subscribe to our YouTube channel, and follow us on Instagram. See you in the next video.